Okay, chapter 9 is all on transformations, and one of the transformations we'll be talking about is a reflection. This is your video on a reflection. Now, what a reflection is, easy way to think of it, is a flip. So if I have a figure, I'm going to flip it over a line, or I'm going to flip it through a point. Both of those are types of reflections, and we're going to focus on those two ideas, over a line and through a point. So I got a couple. We're going to start with over a line. We're going to start by flipping or reflecting this triangle over this line, and what we do is we want to bring it to the other side. It's going to have the same shape. If I could draw, it would have the same shape. Basically the same shape. It's just going to have a different orientation. It's still the same size, but notice it's facing a different way. That's all a reflection does, is it's going to change the way the figure looks, where it's facing, its orientation, but it's not going to change its size. Second example here, same idea. The difference is we reflected over a vertical line. Now we're going to reflect over a line that's on a diagonal. So we're going to flip this over here. Should be about basically the same shape. Okay? And it just flips. It's the same shape again, just a different orientation. The last one here is on a coordinate plane. And this is one causes people some trouble. Now there are rules, and you'll learn those in class and in what we work on in class for reflecting over a vertical or the x-axis, the y-axis through the origin, and then there's two other lines that we're going to learn, the x equals y and x equals negative y. We're going to look at those in class, but here we're going to talk about just reflecting over any line. So I've got a line here, and my line is x equals 2. That's this dashed line. Now to reflect over x equals 2, what you want to do is count the distance from your points. Well, there's 1. It's 1 from our line to this point. So we're going to go the other direction, 1, and put a point. This one is 1, 2, 3. So we're going to go the other direction. We're going to go 3 out, put a point. And then this point up here is 2 away from our point. We're going to go over 2, or 2 away from our line, sorry, and then we connect our dots. Alright? So you're counting the distance away from the line. And it needs to be the same on both sides. Okay? It needs to be what we say symmetrical. And that's reflecting over a line. Now, reflecting through a point, the point that we're going to focus on is the origin. And remember, the origin is 0, 0. I have a coordinate plane. It's right here in the middle. If I'm going to reflect through the point of an origin, one way to think about it, and you're going to learn the rule in class, but another way to think about it is it's a reflect over the x, and then another reflection over the y. Okay? So if I start here, that means I would reflect it this way, over my y, and then I'm going to reflect it down over the x. And I can do those in either order. I could reflect the x and then the y, or the y and then the x. And what happens is that now I've reflected it through that point. So that's another way of thinking about it. And that's what I want you to remember from this video. Okay? So again, a reflection is a flip. We can flip over lines. We can flip through points. You'll learn in class the rules on a coordinate plane for all these different reflections, but in general, it needs to be, your figure needs to be the same distance away from the line that you're reflecting, and if you're on both sides, like it is down here in our coordinate plane, and if you're reflecting through the origin, then you do a reflection over the x-axis and then reflect over the y. In either order, it doesn't matter, and that's a reflection through the origin. And those are your notes on reflections.